Okay, we're back. We're live. 1 o'clock rock. I'm Jay Fidel here on Think Tech, and more specifically on Research in Manoa, and our ongoing inquiry into all the things in the universe. We don't limit our inquiry. We have with us Jeff Taylor, researcher, Hawaii Institute of Geophysics and Planetology in SOAS, the School of Ocean and Earth Science and Technology at the University of Hawaii Manoa, and we have Linda Martell, academic support in Hawaii Institute of Geophysics and Planetology. Thank you again for being here, you guys.
Nice
Always good to be here.
Mainstays to teach us and make us curious about the universe. And today's show is the origin of the Earth and the Moon, inseparable. Wow, that's provocative. We need to know about that. Who wants to start?
We're going to talk about some of the older theories that people had about the origin of the moon, because we've seen that moon up in the sky ever since mankind's been looking up there. So how did it get there? And then we're going to talk about a breakthrough in the 1980s that kind of changed a lot of
drastically changed the way we're looking.
Interesting.
Yeah, and
how
how
come
the
we
theories
were not
are,
advised of this earlier?
yeah.
You didn't ask.
Okay.
So today people are still thinking about these theories and coming up with ways to test them.
So
we'll start
we'll
from
get
the beginning.
into a little bit of that.
Okay.
But this whole idea of inseparable, has been since the space age. These pictures of the Earth and Moon. In Apollo, it was beautiful pictures of the Moon in the foreground and Earth in the background. And then satellites going to other planets started taking pictures of the Earth and Moon from a distance.
Yeah.
And one of the coolest recent one taken, it was taken about actually 18 months ago, I think. This satellite called, it's a deep space climate explorer. And they have a camera on it that has an acronym, but the acronym spells out EPIC.
Epic.
Really,
Perfect.
what a great name. And so
acronym.
it's 1 million miles from Earth, this satellite. And it's in a place where all the gravity balances that we call them Lagrange points. And they, so that it's easy to aim it and keep it aimed at the Earth. And it just looks at the Earth and takes a picture every couple of hours. And
Is
it's
this
been doing
further
it
than the Moon?
Further than the Moon, yeah.
How far is the Moon?
250,000 miles,
Okay,
and this is a
well,
million miles. So it's
okay.
4 times
Great
further.
shot then for a
Yes,
million
and
miles.
we have
You can see
this
it.
film they made of looking at the Earth for 1 million miles, and the Moon goes in front of it, and it gets a picture of it. But what you get a picture of is the far side of the Moon that you don't see from the Earth, because it's always locked in gravitationally, so always the same side looking at the...
Can we see that now?
I think we could.
Oh,
To see
exciting.
the first slide, which
See what
is,
we can
here it
do.
is. Here's the Moon creeping in.
Oh, wow.
Look at that, and that's all the far side of the Moon.
Dark.
It's dark, but not now, otherwise we couldn't see it.
Yeah.
The Dark Side of the Moon was a great album, though. Well, let's do it one more time.
One more time. Can you do that one more time? Get some more detail on it?
And so the Moon doesn't always intersect this view of the Earth from the satellite. And so, but it's neat. And the whole idea of the mission is to look at the Earth, just look at it and to try to understand. It has some other sensors on board, but the camera seems to be so cool. So this is the far side. It looks quite different, not as much of the dark areas that we have on the near side.
Right, we would never see that from
We'd
the
never
surface
see that,
here.
yeah.
So, but here they are close together. Their formation must have something to do with each other.
Yes, they must.
Rather than just some accidental thing, you would think.
Yes.
And certainly, however the Moon formed, we think we know, sort of. But however it formed, it must be informative about the very beginnings of the Earth too.
Yes.
And that's what's so neat about
That's
it.
why we
Yes.
call them inseparable.
Yes.
Right.
I love this discussion.
Yeah. In contrast to like Jay and me, as you would attest to, insufferable. Completely different.
It's not exactly the same thing. So, it's not just logic that makes us believe that the Moon and the Earth, had a relationship or have a relationship. It's got to be science too, right? It's not just logic. What is the science?
Well, the science, first, let's go through the ideas that we had until 1984, literally. And so we have 3 pictures here that we're going to describe. Just
Okay.
3 major theories. They were all in such disfavor that Harold Urey, who was kind of the founder of space chemistry, he said that, well, these theories are all wrong, so the Moon mustn't exist.
There you go.
That's a good one.
So anyway,
Okay,
if you could put up the second slide.
Looks like a bowling
That was
pin.
mine.
It's a bowling pin.
It's a bowling pin. The idea was that the Earth was spinning so fast early on that a blob of it spun off to form the moon. It's perfectly logical for something like that to happen.
But would there be a time when it was all hot like that and molten like that?
It was, in order for this to work, it has to have been that way. And then the question is, were there data that would say that? And the moon and Earth both formed very early, and if they form really hot, then that could actually happen.
You don't sound convinced.
No, no one was convinced about that because it was, you couldn't figure out two things. One was, how do you get it spinning fast enough for this blob to come flying off? And the second thing was, how to, if you get it spinning fast enough, there's too much spin, and you have to get rid of what we call angular momentum. Get rid of the spinning of the Earth, spinning of the moon, and spinning of the in its orbit. It's too much of it. The moon would be whipping around the Earth, and you have to get rid of it. Well, it turns out recently someone has figured that out. But nevertheless, the other problem is, it is testable in principle if the moon and Earth have the same chemical composition.
Okay.
So
Wasn't that idea that the moon spins off the Earth, wasn't Darwin somehow the son of Darwin?
Son
evolved?
or grandson of Charles Darwin had this idea that it spun off, and now he spun off in the Pacific, which is why there's no continents here. That's what his idea
the moon
was.
came from the Earth.
Came from the Earth, right specifically from the Pacific. Well, that can't possibly be because the seafloor is too young and the moon's been there for too long.
But
the idea
old
was
idea.
was very popular, but everyone recognized, even when in discarding that theory, that it had to be early on.
Yeah.
When the moon's, as you pointed out, when the Earth is just molten.
Yeah.
Well, there's another idea. So
Okay.
that's our third picture.
Okay, third picture. Oh, this is interesting.
So this is an idea that the Earth is in the middle there, it's still hot, and then the moon came together at the same time. They sort of, see that ring of rocky stuff? It coalesced into a moon, and so they sort of grew up together side by side, but independently. But that doesn't really work as an idea because the Earth has a very large metallic core and the moon doesn't. So if they grew up sort of at the same time from the same building blocks, why didn't they sort of come out the same?
Yeah. The other thing is there a physical principle about that belt of space junk out there? Can we see that picture again for a minute? You know, that belt? I mean, is there a principle in physics that would say, well, if this stuff is spinning around the Earth as it was then, that it could come together?
Yeah.
There is a principle?
That works out, and in fact, our new ideas have some elements of that in it, and but they do get pulled apart as well. It's like Saturn's rings. It's not one. There's not a single big moon out there. It's a whole bunch of rings, and so the real problem was this iron problem. People tried to work around, but no, even they were not that enthusiastic about how you have so much more metallic iron in the Earth than in the ring of debris. And how the ring gets started was something of a mystery, you know? It wasn't clear. Why not just form one planet? Why this ring? You needed another mechanism.
You also talked about the angular momentum. So if these two things just form together, then why do we have this high angular momentum right now between the system with the way that the moon is orbiting us? So it doesn't quite
work.
Okay.
So then there was another idea.
Okay, wow.
This is the next slide. This one is called capture. This is an idea that the moon fully formed somewhere else and happened to be in the neighborhood of Earth, and Earth's gravity pulled it in and just got it into orbit around us. And people are thinking that the probability of this is very low. And why didn't this moon just hit the Earth like everything, all the other debris? So this is...
Maybe it was going very fast, and it went beyond Earth, and then the gravitational force of Earth
came back,
pulled it back, and then it wound up in a trajectory of some kind.
And if it comes too fast, it just keeps going.
It would just, or maybe skip and keep going.
Right.
And there were really,
just exactly.
It has to be a Goldilocks zone.
Yeah, right.
Yeah.
What strikes me though is that you don't have a lot of debris floating around the size of the moon. That's a pretty big piece of space junk. You come from nowhere.
That's right.
Yeah.
It doesn't happen very much.
It doesn't happen. On the other hand, the Earth formed by coming together of big piece of the space junk from moon size to even up to bigger and bigger. So it's the rarity of the event of capturing that's so hard. Without smashing into the Earth.
Yeah.
That is a more effective way of capturing things.
Yeah, yeah.
So none of these ideas are working.
And then where are we now in the timeline? When was this last theory advanced?
The last, these were all around for quite a while, through the 60s, and of course Darwin's idea of the spin-off was in the 1800s or something like that, I think. But these were the things discussed up into, there were new ideas in the mid-70s, but this was discussed right up into the 80s. In 1983, I was on this committee that gave out lunar samples to people who requested them, made recommendations to NASA on the nature of them. But we also ran a series of conferences about the moon, just to continue the interest in it and make it multidisciplinary so we'd have good use of the samples. And one day we were sitting around, and one of the guys said, a guy named Gunter Lugmeyer, who is retired now from UC San Diego, he said, "Is that one on the origin of the moon?" And everyone said, "Well, that's a good idea. That would seem to be about time. We should just focus on that." And he said, and then we said, "Well, where should we have it?" And then we could tie it to another conference. That makes it economical for people to come. And then, so we said, where's this next? There's an astronomy conference called the DPS meeting, Division of Planetary Sciences. Where's the next meeting? Someone said, Hawaii.
Good thought.
I was not living in Hawaii then. So we all said, ooh, this is obviously the choice. And so it was held in Hawaii, in Kona, in 1984. And at that conference, a whole new idea emerged.
You were there?
Yeah. In fact, I was one of the 3 organizers of the conference.
Linda wasn't born yet.
Oh,
She was
that's funny.
she was an infant, no question about it. Yeah. And anyway, there was 2 papers published. Actually, one was an abstract only in 1975, and they just languished. But the idea was the moon formed by a big impact, but with like a Mars-sized object.
Yeah.
In fact, if you can show number 6.
Oh, this is
Whatever
really
number
getting
5.
interesting.
wait.
now.
Oh no, wait. Show number 5. We'll go back to this.
You forget 6, yeah.
There we go.
I just wanted to show this. That was held at the King Kamehameha Hotel in
Kona,
downtown
yeah.
Kona,
Yeah.
and this is the hallway it was held in. I took this picture in April of this year when I went. My daughter this is an American Youth Soccer Organization meeting.
Okay.
And it was at the same hotel. It was at the same hotel. So I took a picture of the hallway, and the meeting rooms are off to the left. And I just thought I would show that. It's kind of an interesting concept, but the place is still going strong. It's a great place for meetings, by the way.
It's called B-roll. It's, it's sort of leading up to the big story.
Yeah.
And the story would be when you had the conference, and you were there as one of, 3
Three
basic
organizers.
presenters?
Yep. Well, organizers.
And
we
you
had-
found this theory that sounds pretty good, but we can't talk about it right now. Because now we have to take a break. But when we come back,
Sure.
yeah, be better after
It'll
1
be
minute.
better,
Watch
yeah.
this.
Thank you for watching Think Tech. I'm Grace Chang, the new host for Global Connections. You can find me here live every Thursday at 1 p.m., where we'll be talking to people around the islands or visiting the islands who are connected in various aspects of global affairs. So please tune in, and aloha, and thanks for watching.
I'm Ethan Allen, host of Likeable Science here on Think Tech Hawaii. Every Friday afternoon at 2 p.m., you'll have a chance to come and listen and learn from scientists around the world. Scientists who talk about their work in meaningful, easy to understand ways. And you'll come to appreciate science as a wonderful way of thinking, way of knowing about the world. You'll learn interesting facts, interesting ideas. You'll be stimulated to think more. Please come join us every Friday afternoon at 2 p.m. here on Think Tech Hawaii for Likeable Science with me, your host, Ethan Allen.
Bingo, we're back. Think Tech on Research in Manoa with Jeff Taylor and Linda Martell, talking about the origin of Earth and the Moon, inseparable. Okay, we got a new theory on the whole thing. It's going to happen now. Watch this.
Pops out in 1984, and this painting is a very famous painting, number 6. This painting is by William K. Hartman, who is the inventor of the whole Big Impact theory and one of the co-organizers of this conference. The third one was a guy named Roger Phillips, who recently retired from Southwest Research Institute. So Hartman is a painter as well as a scientist, which is a great gift to be able to illustrate your ideas.
Yeah, really great.
So he and a guy named Don Davis came up with this idea that there's a lot of things, kind of, Jay, like you were talking about before, about these things flying around. They like moon-sized objects and even bigger. Well, they thought maybe a Mars-sized object hit the Earth and sent debris into orbit.
Sort of dug a hole and threw
Sort
that
of
piece out.
dig a hole, but it's such a violent event because they're coming in at 15, what's it coming in? Bigger than 25,000 miles an hour, because that's the Earth's escape velocity. And this is a tremendous amount of energy involved. And so it ends up making kind of a ring around the Earth, and we'll show a little movie of that in a bit, but it really is a profoundly important event, and Hartman was able to picture it.
So that sort of goes to the whole thing about gravity drawing objects in space into the Earth because it's bigger and it has the gravity.
And it grows fast, and once it grows fast, but then Jupiter too plays a role in all this because it changes the orbits of things, and so
Because it's big.
Because it's big, and so this object might have come from the vicinity of Mars even. We don't know this for sure, but it comes whipping in and it hits the Earth. The question is, did it happen with Venus? Maybe it did, but it hit head on, so he didn't have the spin to send stuff into orbit and keep it there.
But I have a question. Earlier, we debunked one of the theories because the moon doesn't have the metallic that Earth has.
Yes.
We found no metallic on the moon,
And
therefore there's a real
should
question
go to
about
the
whether
One of
it
the-
came out of the Pacific Basin.
One of the selling points of this idea is that the big impactor, that's the size of Mars, it's the 10th the diameter of the Earth. Hartman actually is smaller in his picture, but it's already molten and formed a core. And when you do computer simulations of these things, when actually certain people do,
The other
I
people.
don't.
Certain people.
The other people.
We have a technical staff that does, and they don't want to be called
Very
technical staff, I don't think.
resourceful.
Anyway, the metal, the big core that is way bigger than the moon itself actually, ends up sinking through the Earth into its core. And the stuff that goes into orbit is from the rocky outsides of the two objects.
Okay, and that
And
would not
solves-
include metals.
And that solves the problem of the
Okay.
metal core, and then it solves the problem too of spinning everything up so that you keep things in orbit. And so it's kind of a satisfying idea. And everyone at this conference, except for 3 people, bought into the idea. 2 of them, one was a carpentry guy, and one was a fishing guy, and you know those people. You just can't
Nothing,
keep it.
nothing.
And but the other guy was this really great lunar scientist, and still is a great lunar scientist, named Paul Warren. He's at UCLA, and he on the field, we had a field trip in between this first meeting and the Origin of the Moon meeting to Kilauea, and at the Volcano Arts Center,
I'm sure.
Hartman has painting there for sale. This guy Paul Warren buys the painting.
Perfect.
And at the end of the conference, he was one of the people who didn't buy into the idea yet.
He bought the painting, but not the idea.
Not
in
the
painting.
idea, yeah. Still owns the painting.
He wanted to get it off the market.
He still owns the painting and has it on display beautifully in his house and taken care of with special lights because he knows it's
Knows it's
an important thing.
In his heart, he knows it's
Well,
right.
almost everyone has bought into aspects of this whole thing now. So.
Okay, let's look at the simulation now, okay? Or you
Well,
want to
one
look
more,
at something-
one more quick
one
point.
more-
Oh, here it is. Yeah,
Okay,
take a
there
look.
it is, okay.
This is done by Robin Canup, who's at Southwest Research Institute in Boulder, and there are 2 objects come smashing into each other, and it'll play
Okay,
again. We
let's-
just have to have time. It'll
Play it again.
When the 2 objects hit, there's a color
There we
coding for
go.
temperature. The redder it's hotter. The temperatures of the really hot things get up to 7,000 Kelvin.
Oh.
And then you can see all the debris around the moon. The little circles are actually little analytical grid points in the calculations. These are called 3D hydrodynamic codes.
Of course they are. At dinner, my
That's
wife
what
and
I
I
call.
speak of little else.
Really, you can't. I don't go a day, do I, without saying 3D hydrodynamic
Hydrodynamic.
code. No,
So those codes are driven by the real chemical evidence that we have from the rocks that the Apollo astronauts
they-
brought back, and the isotopes. And
One of the interesting
This
things
is not in a
about
vacuum, so to speak.
No, they're bringing
and computer power. The beauty of this 1984 conference is that computers had become cheaper, And so you could have a little laboratory computer and run simulations. They were simpler than they are now, but that came along, and our knowledge of the impact process came along. So these two things could be combined, and now all those things are much better than anything else, and just as our chemical analyses are better than they were then.
Yes.
So it's really is great. And an interesting thing about one of the interesting things about the big impact idea is that it actually ties elements of all the other ideas together.
Yes.
And so the slide 7 shows this.
Remember
Okay.
those other pictures we showed? They have those names, fission, capture, and co-accretion growing together. And where they all intersect in ideas is that big impact theory now. We call it the giant impact theory hypothesis. So we're still working on that. That's what all of the
But it
effort is in.
has some aspects. You know, the impact
Each-
chips things off, doesn't quite chip it off is not the right thing because it melts so much of it and vaporizes even. I mean,
Yeah.
after this cloud contains rock vapor. I mean, this is so high.
Rock vapor.
Yeah.
Wow.
Wow.
But and it goes around, so then it becomes there's a cloud of stuff
Like-
accreting around the Earth, just like the co-accretion.
Yeah.
But it captured it too because some of the material is coming from the big impactor. And it does kind of fission off a lot of material from the Earth, so it has elements of all of
all
it.
of the ideas.
So it's like the Henry Clay Great Compromiser theory of the origin of the
Yeah.
moon. You know, it blends everything together.
Can we look at that one more time? Just want to.
The Robin.
Okay, so
Oh.
I understand the capture because the capture assumes that it's coming from space somewhere, and the modification is instead of going around the Earth, it hits the Earth. I understand co-accretion because, well, I'm not sure I understand the implications of co-accretion and big impact. And with fission, I don't understand that because fission assumes that it came from the Earth. Well, it did
It does.
come. Yes,
but
it did, yes.
It isn't all of it. It's some of
Some
it.
of
And
it.
the two
Okay.
things
Oh,
may
wow.
merge, and there is isotopic evidence that suggests that they merge completely. I mean, they got homogenized. Whatever the composition of the big impactor and
Came
the
off
Earth.
sort of like that.
Yeah.
What about
so
the co-accretion one?
the co-accretion is, once you do this, and you remember at the end of the simulation, which we should show again because it's so cool. That's from the internet. You hear about that? You hear about
I've
the
heard of it,
internet?
yeah. I know I've
And
heard
but once at the end of it, you see this disk of stuff around it. Well, the moon forms in that. So in that sense, it's at that stage, it's co-accreting. The Earth is already formed, so that's a different. But it accretes around the Earth.
So what is this, this theory?
Oh, here it is, yeah.
Oh, there it is. Okay, so this is what happened when...
If
Right.
something hit the
Something
Something
hits
hit
the
the
Earth,
Earth.
and they do there's a lot of variables: the size of the object, the velocity of the object, and the angle with respect to the.
This would be consistent with geophysics, geophysical
Yes.
principles.
Yes.
Yeah,
Yes.
yeah. It really is an interesting thing.
Well, yeah, I wanted to explore that. So here we are, and we've found a theory that works, that adopts accidentally or on purpose, all the three theories from before. And now we have a better guess as to what happened and how the moon, okay, but what does this teach us in a larger sense? What have we learned here that would be useful in space travel, that would be useful in understanding, the formation of other moons and places?
Around other suns.
Around other stars?
Yeah.
I mean, it sounds like
Planet.
it would be, it's a breakthrough of sorts, but what is it?
Conceptually, I think one of the most interesting things is that it tells us planets. There was a theory at first, and then becomes a little more advanced, or a hypothesis at first. You're making a guess, and then it becomes firmer and firmer. That the planets, the inner planets, did form by little things coming together. Starting with dust that became asteroid-sized, and the asteroids became moon to Mars sized, and these things all kept whacking into each other until they were either ejected from the solar system by making a close pass to the sun or something, or made a bigger planet.
Yeah.
And there is hints that this is going on when we look at other stars, and other.
The astronomers are looking for this kind of situation. Around other stars, are there Earth-like planets with moons similar to ours, like a
Similar to
system
ours.
like ours?
And
But it could happen again. Maybe not here.
Not
Maybe
here.
We're an older solar system, am I
Yeah.
right about that? But it could happen somewhere else, and we
Oh.
could actually,
in principle, we had a PSRD article that was written by one of our graduate students with a faculty member who is in could have been in the Institute for Astronomy, but he's in geology and geophysics, one of these broad multidisciplinary
isn't
people
it?
by
Yeah.
Eric Gaidos, his name is. I don't know if you've ever met him. And David Trang was the student. It was part of a course project, and there was a signal in the infrared around one of these very young stars that you can interpret as a big collision.
A collision like this would happen instantaneously, or in slow motion?
Well, the event that ends up making the first ring around the Earth, where there's a lot of debris and it's hot, is a week.
A week.
A week.
And
We're
then
talking about big numbers
the
here.
moon would form, half the moon could form. These are simulations done by Robin Canup, who showed the one, who made the one that we showed.
Yeah.
That it's a week to make half the moon, and then a couple hundred years to finish the job. This is instantaneous. I mean, on a
When we're
geologic
talking
time
about billions of
Yeah,
years.
well,
yeah.
in the Bible, they talk about how it took so many days
Yeah.
to do this and that. So maybe there's something we can learn. In the
From
Bible.
this.
You guys are great. This is terrific. This is a great examination. So it puts us there. It puts us there in space watching these things happen. So
Yeah,
thank you
yeah.
very much. Linda, you're great.
Been great.
Linda Martell, Jeff Taylor, you guys are fabulous.
Thanks, Jay.
Thanks, Jay.
Thank you so much, as always. Come back soon.